Hello, ladies and gentlemen. Welcome to review Chapter 8, Perms and Coms. Okay. Now, first thing to remember, the fundamental counting principle. Okay. Now, this is straightforward. Occasionally, you see a question on this. Say you have 3 shirts, 4 pairs of pants, and 2 belts. How many outfits can you make? Well, that's pretty straightforward. You think about it for a moment. That's 3 shirts, 4 pants, 2 belts, which is 3, 4, 12, 24. Yes, that's about it. Now, that's pretty straightforward, but there are a couple of tricks to this. The most common one is you've got 3 shirts, 4 pairs of pants. You don't know how many belts you've got. And you make 48 outfits. How many belts do you have? 12 times something equals 48. Something equals 48. Or I could call it X, but that would look like my multiplication symbol. That's the first part, fundamental counting principle. Read the question. Okay? Now, moving on. The rest of this, or the second important part, permutation and combination Now here, this course is slowly turning into a language arts program where you have to read the question very, very, very carefully. But most of this confusion can be avoided if you've gone back to the video where I introduced this unit and talked about perms and coms. Now, my favorite example of this are the 30 kids in kindergarten running a race. Back to the video. 30 of them run a race. How many ways can they finish? 30 factorial. 30 choices for first place, 29 for second, 28, yada, yada, yada. The important part that so many people forget about is you have to account for everybody. So that's 10 winners, 10 as good as winners, and 10 almost. Because of course, kindergarten, they can't lose. They all have to be winners. Now, if you can account for everybody in the denominator, you can answer the question. So, let me give you an example. Combination versus permutation. You have 6 people in a group. You need to choose 3. A committee of 3. Now, here is order important. You don't know because I've been deliberately rather vague with the question. Committee equal. Then order is not important, and it's a combination. Now, this is 6 people. How many ways can you choose 6 people? But there are 3 on committee and 3 lucky ones not on committee. Now, this is also equal to 6c3, and if you remember the formula, that's n factorial, n minus r factorial, r factorial. They do talk about the formula occasionally. I haven't seen it in the new exam, but we've done enough practice questions. You should be comfortable with it. So that is If order is not important, you just have 3 people. That's a combination. Now note, you can do the formula. You can fill this in, or you can do the formula, whichever works, or you can even plug numbers into here. Whatever works for you. Now, committee of 3, same committee, same group of 6, committee, president, VP, secretary. Now all of a sudden, order is important. Now, if order is important, this becomes a permutation. Remember what I said? You do not have a combination lock on your locker. You have a permutation lock. Just ordered. I don't know why they call it that. So, up here, once again, we make a list. We have, or we figured out, we have 6 people. President. One way to choose the president, one person. One vice president. One secretary. And the 3 lucky people not on the committee. Now, if you think about that, that's the exact same as 6p3, which is n factorial for n minus r factorial. Now, permutation versus combination. So as long as you can figure out your numerator and denominator, you don't really need perms and combs, unless, of course, they ask you for the formula. But we'll get to that. So, a couple for you to practice on. How many ways can you arrange the letters in the word Toronto? Sorry, Toronto, for all you non-maritimers out there. I think about it for a moment. You have 1, 2, 3, 4, 5, 6, 7 factorial letters. But you have to look at repeats. How many T's do you have? 2 T's. 3 O's. 1 R. And 1 N. Now, when I did this permutations with repeats, I usually didn't bother doing the 1s at the end because I'm lazy. I really should. Now, remember that? Good. I'm going to show you a few of the tricks. So, let's look at Alberta. Now, tricks or restrictions. So how many ways can we get this, Alberta, to begin with a vowel? Well, this A, begin. Well, there's 1, 2, 3, 4, 5, 6, 7 letters. 1, 2, 3, 4, 5, 6, 7. What's my restriction? A vowel must begin. This is begin with a vowel. Now, how many vowels do we have? 1, 2, 3. So I have 3 choices for my first letter. Now, once I've done that, how many letters do I have left? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yes, 6. So I've got 6 choices for my second. 5, 4, 3, 2, 1. So that is 3 times 6 factorial. Now, what have I forgotten to do? I have repeats. I have a pair of A's. So be careful about that. Okay, now that's the basis I'm going to pause the tape, stop the recording now. I want you guys to review this. Then we're going to go on and look at some nastier examples with more restrictions.